G'day everyone, video number 6 or 7 or something for today. I thought I'd try and tie a few things together, the forms of a vector equation. There's lots of different forms and the examiners will assume that by saying something to you, parametric, Cartesian, vector form, you're just going to know and you're going to understand it and be able to answer in that form. So let's take an example here and let's convert it to a couple of different forms and see that we know what's going on. This here is the vector equation of a line because we've got a start point and a direction. Okay, so that's the vector equation of a line. Let's just drop that in. Vector equation of a line. Right, vector equation of a line. Now, we might want to transfer it into this form, and this is what we call parametric. Okay, now para means two, metric means to measure. So two equations that are measuring something. What do we need to do? Well, I'm going to put it over here. We need to break this up into the x and the y coordinates. So this and this are my x coordinates. So let's work with that. Let's get x equals, I'll jot it in here in a minute, x equals 2 plus lambda. Now I haven't written any I in there because the I and the I don't need to write that because by saying x equals, x-axis and the y-axis are the same thing. Then I can say y equals 2 plus 2 lambda. So there we go. There's my parametric. Let me rewrite this a little bit further away. There's my parametric. 2 plus lambda and 2 plus 2 lambda. Both are describing what is going on. So this is, I call this my parametric equations. Okay, parametric, right. Now, that's fine. I can see this to here, that's okay, and I can probably go from here back to here. That's okay. But what if I eliminate the lambda part? Let me get rid of the lambda part and see what happens. So over here, now have a look at this. These two equations here, I'm going to rearrange them to be lambda equals. Top one is going to become lambda equals x minus 2. And the bottom one here is going to become 2 lambda equals y minus 2. Now initially that might look like a problem because this is the same here, minus 2. It's not really because I've got 2 lambda and lambda. So let me go through and just put a 2 here, a 2 here, and change that to a 4. Of course, with a linear equation that wouldn't be a problem, I'm just doubling everything. Now if I subtract one away from the other, this will then be 0, the lambda's gone. That's good, that's what I want. 2x minus y minus 4 minus 2. So if I move the y over here, I'll get y equals 2x minus 2. So that there is now, after I eliminate the lambda, I get y equals 2x minus 2. That's my Cartesian form. Now, it's pretty easy to spot that it's the Cartesian form because it's all in terms of x and y. There's no i's and j's and lambdas and whatever going on. So, Cartesian form in terms of x and y. Parametric form, two separate equations, one describing the horizontal, the x motion, one describing the vertical and the y motion. Para meaning 2. And my vector equation of a line where I've got a start point and a direction that I'm heading on. All three tell me exactly the same information. The only difference is kind of what I want and what's handy to the particular question that I'm doing. Hope this has helped. This is a really good thing to get a handle on, so please do make sure you know the language of it. Catch you later.